Alright guys, so today's going to be our second day of writing linear expressions from tables. I still want you to be able to write a linear expression and also check at least one solution. So 1 and 2 are really just review, but I want to cover some misconceptions that a lot of students thought. So if you guys remember, when you have tables, some are going to be linear, some are not. If a table is linear, your life is 10 times easier. Now, what does it mean to be linear? Linear is like a straight line that's going at the same pace over and over and over. So the easiest way, or the only and the easiest way to check in a table is just to see if each of the x and y values are going up by the same amount. So if I look at these x's, I can see that all my x's are getting added by 1. I can see that when I look over at my y's, all my y's are being added by 2. So it's a constant change. When your x's move by 1, your y's move by 2. When your x's move by 1 more, they move by 2 more in your y's. So it's a repeated pattern. That's what makes it linear. Whenever it's linear, it is super easy to write a expression to represent that table. Remember, you always want to start with your starting point. Now, your starting point is the y value whenever your x is 0. So if I look at my x's here, look at your x's. Where does your x equals 0? The x is right here. That means the starting point is its y, so it's 2. So we are starting with 2. That is my starting point. I'm going to add it to my common difference, and my common difference is whatever I'm adding to my y's each and every single time. I see that I'm adding 2 each and every single time. How many times I add it depends on which x value. So I'm just going to attach my little x there, and now you have your expression. Just like that. Just got to look for those values and know where to place them where. So that's cool and all. Now we have to go and verify it. So I'm going to try a 3. I'm going to do a different color so that way you can see it too. I'm going to plug in a 3 to see if I get an 8 out of my expression. So 2 plus 2 times whatever my x is, and my x is 3. Now looking at this, remember your rules of PEMDAS. There's no parentheses, exponents, but there is multiplication. 2 times 3 is 6. So I end up with 2 plus 6, which is 8. You'll notice that when you plug in a 3, you get an 8 out. So it checks out. Again, when I'm grading your guys' work, there are 3 things I want to see. I want to see these little numbers along the tables to ensure that you know what a linear is. I want to see your expression, and I also want to see you verify it. So there's 3 things that I want you guys to do there, okay? So make sure that you're doing that. All right, so the very next one, a little more quicker here. Again, whenever you're doing these, you need to check to see if your table is linear. I can see here from -2 to -1, I'm adding 1. From -1 to 0, adding 1, and then I'm adding 1 again. Over at my y's, how do I get from -8 to -3? Well, I know I am minusing 3. So I look and analyze my table, and I see that I'm adding 1 and minusing 3 each time. This table is linear. So that means I'm able to write an expression very easily. I look down my x-axis. Where does my x equal 0? It is right there. What is its y? It's a -14. That is my starting point. Now notice here that your common difference, when we add it, is a -3. Don't get freaked out by that. It's just a -3. You're adding -3 each and every single time. Don't forget the amount of times that you add it depends on how far down your table or backward you go. So there's my x. Now keep in mind here that whenever you have a plus and a minus, we can simplify that, because what's a positive times a negative? Well, it's just a negative. So I'm going to simplify this to just have a -3x, and it's a little more simplified. Am I going to mark you wrong? Probably not, but it looks a little cleaner. So let's check our solution. I'm going to do it in a different color. Looking along this whole list, I'm going to plug in a -1 to see if I get a -11. So -14 minus 3 times my x of -1. Again, rules of PEMDAS start with multiplication. A -3 times a -1 is a positive 3. -14 plus 3, a positive 3, is a -11. It checked out, so that means I am okay. All right, so attempt to do the number 3 and 4, 5, and 6. You'll notice that numbers 3 through 5 have something very unique about them. I'm going to let you guys kind of think about it. Press pause if you need to. What I'm going to do is just go ahead and go from there. So what I like to do is I like to do things in order whenever I see a problem. It helps me get faster, so when I'm in test, I'm not in a hurry. If they tell me to write a linear expression given a table, the first thing I do is check to see if it's linear. I'm not worried about anything else. I'm just worried if this table is linear. I can see clearly here that my x's are adding 1 and my y's are adding 5 each and every single time. Now this is linear, so that means I can write a linear expression just like I did before. But look at your x's. What do you notice when you look at all these x's? Remember that your starting point is whenever your x equals 0, but there is no x equals 0 value. So what do we do in this situation, or what can we do? So let's think about this here. Notice that this table is a pattern. They don't show us all the values. For instance, this is 1, 2, 3, 4. The next value would be 5, and so forth and so forth. Now let's work backwards. If this is a 5, this would be a 4, 3, 2, 1, and then the value of 0 would be up here. You can write it in there, or you can also write it up. I think that looks a little bit messy, so I'm just going to continue my table going the other way. There is my x equals 0. Now what is its y value? If I look at my y's, which I'm going to change colors so that way you can see, it goes 15. If I'm working backwards, that is. I can see if I'm working down, I'm adding 5 each time, but if I'm working backwards, what am I doing? It goes 5, 10, 15, 10, 5, 0. 0 minus 5, because I'm minusing 5 each time, would be a negative 5. Write that a little bit cleaner. Negative 5. So what I'm doing here is I'm just analyzing my table using the patterns to work to my advantage, to work backwards or forwards to figure out what is the value when x equals 0. My x's, I worked backwards. I saw that I was adding 1 going down, so I'm going to minus 1 going up. And my y's, I noticed that I was adding 5 going down, so I'm going to minus 5 going the other way around. And after that, it's really easy because I know what my starting value is. My starting value is a negative 5. I'm going to add that to my common difference, which is a positive 5. Now remember that how many times you add it depends on the x, right? So that's why I added my x. And now I'm going to check it. I'm going to input a 3 to see if I get a 10 out. Negative 5 plus a positive 5 times a positive 3. Let's do the math. 5 times 3 is positive 15. Negative 5 plus 15 is a positive 10. So I can see that it checks out. All right, so very next one. A lot of the same here. You need to figure out, okay, where is this table even linear? I can see here that from negative 4 to 1, I am adding 1, adding 1, adding 1. Let's see what happens with my y's. I am adding 5, and adding 5. So this is linear. Notice that when I add 1, I'm adding 5 each and every single time. So that means I could write a linear expression really easy, but I need to know where my x equals 0. Now I'm looking at this guy here, and there's no x equals 0 value, so I have to find it. Now let's think about this. If I work down, this is negative 4, negative 3, negative 2, negative 1. What is the very next value down the pattern? It is a 0. So notice that I just continued my pattern. I kept adding 1 because I knew my 0 was somewhere at the bottom of that table. Now let's do the same thing to the y's. I can see as I'm going down my pattern, I'm going to go 20, 15, 10, 5, and if I'm minusing 5, I guess it would be at a 0. I barely caught myself and noticed that I said adding 5. Don't make that mistake. Notice that I was minusing 5 each and every single time. So don't be like me. Make sure that you are saying what you're writing at the same time. Okay. All right. So keep in mind that take your time, see the patterns, analyze them, and go from there. So I see here that on my starting point, again, I'm looking for my x equals 0. I used my patterns in the table to find my x equals 0. Now its y is also 0. Luckily for us, my starting point is 0. I'm going to add that to my common difference, which is a negative 5. Not a positive 5, a negative 5. Don't forget your x. Now remember that whenever you have a negative and a positive right next to each other, a negative times a positive is just a negative. So I'm going to simplify that. I'm also going to notice that 0 minus anything or 0 plus anything is just itself. So that means I can even simplify it worse and just end up with a negative 5x. Now let's test a problem. Let's test negative 4 and 20. I'm going to plug in negative 4 for my x, so negative 4 times, or negative 5 times negative 4. Negative 5 times negative 4 is a positive 20, so notice that it checks out. All right, so cool. So what I'm going to do now is I'm just going to scoot this program a little bit more so we can work on 5 and 6. So make sure you write all that down. Make sure you have all 3 of the work I want you to show there. All right, so let's continue. I'm getting in a, like how would I say, a pattern, a routine that whenever I see a table, the first thing I'm going to do is just check to see if it's linear. I notice that these are adding 1s. My y's are adding 4s each and every single time, so I clearly see that it is linear. Now notice here that I do not have my x equals 0. I looked everywhere and those x's is not there, but look at your pattern. I know it's somewhere up here on the table, so I'm going to go 5, 4, 3, 2, 1, and 0. So now I have to figure out what that value is. So let's look at our y's. Going down, I'm adding 4, so going backwards, I'm going to minus 4. So 16, 12, 8, 4, 0. And then minus 4 one more time, I end up with a negative 4. So again, use those patterns. Make sure that you're going the right direction. Don't be like me over here where I made the mistake on number 4. Always double check to make sure. And then after this, it's kind of like a breeze, right? Because all you need to do is like, okay, what's my starting point? Well, here is where my x equals 0. That is its value, or its y value, which is negative 4. I'm going to add that to the common difference. Keep in mind that the common difference is whatever you see is happening each and every single time. So I'm going to put a positive 4 because I'm adding 4 there. And then my x that goes along, okay? The biggest mistake that I see students do is they'll figure out that it's linear going in one direction, and then they're like, okay, to work backwards, I'm going to subtract 4, and then they put the subtract 4 as their common difference. Keep in mind that whatever you verify here, that is your common difference. So always, always, always do that there, okay? Or always do that common difference that you have within your table. That's what's another good thing about writing it down. Now let's check our solution here. I'm going to check to see if 4 works. So I'm going to plug in a 4 to see if I get a 12 out. So negative 4 plus 4 times 4. Again, I'm plugging in a 4 to see if I get out a 12. I'm doing the math. 4 times 4 is 16. And then negative 4 plus 16 is a positive 12. So it checks out. Awesome. All right, so last but not least, I can see here that I have a table. Let me check to see if it is linear. I am adding 1 each and every single time. Notice that in my y's here, I am also adding 2 each and every single time. And now I need to figure out my linear table, or my linear expression for that table. Now, is there anywhere my x equals 0? Yes, it's there. That means that y is my starting point. Now I'm going to add that to my common difference of 2. Don't forget your x. And now all you have to do is verify to make sure that you are correct. So let's do that with negative 2. And let's see if we get an 8 out. So negative 4 plus 2 times a negative 2. Whenever I have a negative, I like to show times with a parenthesis, but it's the same thing. 2 times a negative 2 is a negative 4. And negative 4 minus 4 is a negative 8. So it checks out. We are correct. So make sure you're showing all your steps, not just an answer or something. I need to see your work to ensure that you guys are understanding this.